Hey guys, Mr. Backerberg here. In this video, we're going to be looking at end behavior of polynomial functions. As we're looking at the end behavior of a graph of a polynomial function, we're going to focus on the degree of the polynomial, so the highest power we see within our function. And we're going to split our functions into two categories. The highest power could be an odd number, or the highest power could be an even number. And depending on what we're seeing, each type of graph is going to have its own specific end behavior. So the first thing we're going to take a look at is if we have a function with a highest power with a degree that's an odd number. So we've got some graphs in front of us, and these are just general polynomial functions. But what I want you to keep in mind is that the highest power is an odd number. Now, I don't want you to look at what's happening in the middle of the picture. I want you to focus on what's happening on the ends of the picture. And the first thing that we're going to look at is if we have a leading coefficient that is positive. Then what's going to happen is as we move out to the right-hand side with our x's, notice that our graph is going up. So the limit of our function as x approaches infinity, so as x goes to the right, then our function is also going to approach infinity. So as we go out to the right-hand side, our function is also going to be increasing. Now as we work our way to the left-hand side, so the limit as x approaches negative infinity, then our function is also going to approach negative infinity. So as we go to the left, then our function is going down. Now if we adjust things a little bit and have a negative leading coefficient, then a negative leading coefficient is going to flip our graph over the x-axis. So now the limit as x approaches infinity, so as we work our way out to the right-hand side, now our function is decreasing going down to negative infinity. Or vice versa, if we look at the limit as x approaches negative infinity, so as we work our way out to the left-hand side, now our graph is increasing up. But the big thing about odd functions is that the left and the right side of our graph do opposite things. One side of the graph always has to be going up, and one side of the graph always has to be going down. And it depends on if that leading coefficient is positive or negative. If your leading coefficient is positive, then your graph will go up as you move to the right, but it will go down as you move to the left. And if we flip-flop that to a negative leading coefficient, then our graph is going to go up as we move to the left, but down as we move to the right. Now, if we adjust that degree of our polynomial function to be an even number, so an even-powered function, again, don't focus on what's happening in the middle of the graph, but look at the ends. And we're going to start by looking at a positive leading coefficient. And what I want you to notice is as we work our way out to the left, so the limit of our function as x approaches negative infinity, and also as we work our way out to the right, so the limit as x approaches positive infinity, both sides of my graph are going up with that positive leading coefficient. So going to the left, our graph is increasing, but also going to the right, our graph is increasing. Now if we shift that to being a negative leading coefficient, so again that negative leading coefficient flips our graph over the x-axis. So as we work our way out to the left, so the limit as x approaches negative infinity, and as we work our way out to the right, so the limit as x approaches positive infinity, now both sides of my graph are going down. So if your degree is even, then both sides of your graph will display the same behavior. And it depends on if that leading coefficient is positive or negative. If your leading coefficient is positive, then both sides will go up. So we're going to go up as we move to the left and also up as we move to the right. But if your leading coefficient is negative, then we're going to go down on the left and down on the right. So we're going to take a look at a couple of examples where we are given a polynomial function and we want to talk about its end behavior by looking at its degree and its leading coefficient. So the first function we're going to take a look at is f of x equals x cubed plus 2x squared minus 11x minus 12. Now this looks like a big, complicated looking polynomial function, but the only thing I care about in here is the term with the highest power. So I'm looking at the very front at that x cubed. So I can see that my highest power is an odd number. And I can also see that my leading coefficient, the number in front of that highest powered x, is a positive number. So this tells me something about the end behavior of my graph. With an odd-powered function, the ends have to have opposite behavior. And because the leading coefficient is positive, that means our graph is going to go down on the left-hand side and up on the right-hand side. But we're going to look at that in a little bit more of a mathematical way, and we're going to write that out using limit notation. So we're going to say the limit as x approaches negative infinity. So as we go to the left, then our function is going to also approach negative infinity since it's going down to the left. Now if we wanted to look at our graph as it's going out to the right-hand side, we would talk about the limit as x approaches positive infinity. And our graph is supposed to be going up, so then our f of x is going to approach positive infinity because we're increasing as we move out to the right. And I can graph this out on my calculator to confirm the behavior. So I've got my function typed into my calculator. I did adjust the window a little bit. My x min is still at negative 10 and my x max is at positive 10, but I made my y minimum go to negative 25 and my y maximum go to positive 25 just so we can get a good view of what's happening with our graph. So now when I hit graph, I can see that the left side of my graph is going down and the right side of my graph is going up. Now we're going to take a look at another function in here. So we're going to do the function f of x equals 2x squared minus x minus 3x to the fourth. And again, the only thing I care about in this function is the term with the highest power. So I'm looking at that negative 3x to the fourth on the back end. I can see that the highest power is even, so that means both sides of my graph should do the same thing. And I can also see that my leading coefficient is negative. So that means my graph has to go down on the left-hand side and also down on the right-hand side. But we're going to write this out in our limit notation. So the limit as x approaches negative infinity, so as we go to the left, then our function is going to approach negative infinity since it's going down, and the limit as x approaches positive infinity, then our f of x function is also going to equal negative infinity because again we're going down on the right hand side. And again we can graph that out on our calculator to confirm its end behavior. So I've got my function typed into my calculator. I just want a standard viewing window, so I'm going to hit zoom 6 to get my 10 by 10 window, and I can see as I look at the graph it's going down on the left hand side and down on the right hand side. That's going to be it for this video. Thanks for watching.